Saxon Math 7-6, lesson 107. We have two parts to this lesson. The first part is about angles. Okay, I know you've probably heard me talk about angles before. You may have studied them in other classes. That's okay. What we're going to do is we're going to build on what you already know, and at the same time reinforce what you already know. It's a concept of learning that John Saxon uses all the time that I'm a huge fan of. It's called spiraling. And what it means, if you can imagine this three-dimensional, is that here we introduce an idea. Then we go and we talk about other things for a while, and eventually we come back around and we talk about X again. But this time we add a little bit of something more. And then we go away and we talk about something else for a while. But eventually we work our way back and we talk about X, but we've added a little bit more this time. Do you see what I'm saying here? So talking about things and then not talking about things and then coming back to them and adding a little bit more, that's what spiraling. It's a way of reinforcing and building upon what you know, always working to a higher level. Now for students, this sometimes can feel frustrating, Joel, because when you come back around to it, some students quickly say, I already know this. I've heard this before. I don't need to hear it again. And I understand that familiarity, but if you will stop and just allow yourself to be a part of this process, what you'll learn is that your brain actually understands it much better the second time you hear it. And then we can add maybe just a little nuance, just a little something more. And then we go away for a matter of days, weeks, even months. And then we come back and we build a little more. This is how we build long-term memory, to use one way of thinking about it. The other way is we build true understanding. You're not just, pardon my language, you're not just vomiting up facts that got shoved into your brain the day before. You truly understand something. And that's what I'm going for, you guys. I'm not trying to just cram a bunch of facts into your head for today or tomorrow or the next week. I want you to remember this stuff so when you're in college, the foundation of your mathematical knowledge is strong. So that's why we do what's called spiraling. That's why I love the Saxon curriculum. I use spiraling in all my teaching when I was teaching many different subjects. This makes a difference, you guys. So when you see an old topic come up, go ahead and sigh and go, angles again. We always talk about angles. But just hold yourselves open after that point to recognize that maybe I'm going to say something different. And even if I say all the same things, it's going to sit in your brain differently because you understand where to put it. My friend used to describe it like this. If you think of this as a series of hooks or pegs, right? Think of them as pegs on a peg wall, right? When you come back and hear something that you've already had before, you already have a place to hang that information. So let's pretend this says here, let me make it bigger. This is your peg where you're storing information about angles, okay? Well, you've already heard about angles. When I come back to talk about angles again, you say, oh, I'm gonna hang this new information about angles right here with my old information about angles. You connect them in your brain. Super important, super useful. Embrace the spiraling. Okay, I'm done talking about that. Now let's talk about angles. This is a right angle. It is measured, as all angles are, by something called degrees. And a right angle has 90 degrees. That's the symbol that means degrees. Okay, then we have something called an acute angle. An acute angle is measured less than 90 degrees, right? It's smaller. And then we have what we call obtuse angles, and those are greater than 90 degrees, but less than what we call a straight angle. And a straight angle is 180 degrees. It's perfectly flat, right? And just as a reminder, if you go all the way around in a circle, that is 360 degrees. We'll talk more about that as we go. And if you want to take a circle and divide it up into 4 equal bits, look, you've just created 4 right angles. This little square in the corner is a symbol that means it's a right angle, and each one has 90. And that's how we get to the total being 360, because 4 times 90 is 360. We can also see that if we just take half the circle, that's 90 plus 90, that's 180, and there's our straight angle. Oh, it all comes together. Those geometry dudes, they're smart. Okay, so now how do we use this in mathematics? What do we do with this? Example 107.1. Here's a picture. I do recommend that you draw the pictures if you're even slightly confused, because it'll always help you figure it out. Okay, if angle X is an acute angle, then what type of angle is angle Y? Well, you can flip over the page, but I remember that Y, the word for that is obtuse. This is just John trying to make sure you understand the vocabulary. Example 107.2. Okay, same kind of picture. X on this side, Y on that side. We've already established acute and obtuse. Okay, cool. Together, angle X and Y form a straight angle. Okay, I see, like this, right? The two of them add up to this. As soon as I hear straight angle, my brain reminds me straight angles equal 180 degrees. There's no rules about how many degrees are in an acute or an obtuse angle because they can change, right? But straight angles always add up to 180. If the measure of angle X is 60 degrees, and that seems right because we see it's acute, so we know it's less than 90, then what is the measure of angle Y? Okay, well, we know that X plus Y has to equal 180, and we know that X is equal to 60. So we can see that in order to add up to the total, Y has to be equal to 120 degrees. Does that make sense? 180 minus 60. Final answer. Example 3. Name 3 angles. Oh, let me draw you the picture first. Sorry. Ah, that's a square, not a crazy. Okay, so we have a square that is divided into 2 triangles, actually, right? But we can look at those as angles. And then it has letters at the corners. Name 3 angles that have their vertex at point A. Okay, vertex means if you have an angle, the vertex is the point where the 2 lines come together, all right? So we're looking at point A as the vertex, and we're trying to see 3 angles that are oriented with A at their vertex. I'm gonna use different colors to help you see them. Okay, so here's one, right? Like this. And that would be angle DAC. And I get those letters by following beginning, middle, other end, right? Okay. And then there's one on the other side, right? This angle. And this would be angle BAC. And then we also have this one, right? Angle DAB, angle DAB. That's a right angle, isn't it? These are 2 acute angles, right? These guys are acute, and then this one is the right angle that also has its vertex at point A. DAC. Okay, I just want to point out one thing. These are correct. John writes this one slightly differently. John says that this angle, he refers to it as angle CAB. Okay, how did he get that, and is it the same as ours? We're looking at this darker teal colored angle. Okay, he went CAB, and we said BAC. It's the same angle, we just described it from opposite ends. This is the same. So we're fine. John's answer just has been given in a different order than ours. All right, now we get to do another topic in this lesson. This is a thing that John does more and more as we go on in his book. He'll break a lesson into different sections using letters. Oh, I need a new piece of paper. That's what I was trying to do. So this is part B, and this is called two-step equations. All right, and here is what one of them would look like, 107.4. Okay, there is an equation. We want to start solving it. Now, I'm going to tell you some stories that may make you go, what are you even talking about, lady? But after a while, this will start to make sense. We always want to isolate the letter. In order to solve equations that have letters in them, we want the letter by itself on one side of the equation. How do we get rid of the 3 and the 1 that are hanging around with it? We want to push all the numbers to the other side of the equation and add or subtract them or whatever it is we need to do. So we do the opposite. How do you know whether to get rid of the 3 first or the 1 first? Let me tell you a story. Have you ever been a part of one of those friendship groups where there are 3 friends together? Okay, now this always happens. There will be 3 friends and everybody's friends together, but almost always 2 of them are a little bit closer than the 3rd. Oh my gosh, growing up I was involved in way too many of these. Even as an adult, you see it all the time where, yeah, we're all friends, but you guys are kind of closer friends and this is kind of less closer and less close. And there's always that awkward moment, if you're this person, which I've been my fair share of times, where you're this person and you realize, oh, you were all 3 hanging out, but now you're going to leave and they're going to stay together. And it's always a little bit awkward, right? So this is the friend, but not the best friend. And these are the BFFs. And this is just the friend. Now, we're going to take this weird and somewhat random story and we're going to apply it to this kind of expression. Right? On this side of the equal sign, this is what we got. These 2 are best friends, and this is just the random friend. I'm going to call that the random friend. Even though everybody's good friends, this one's just the random friend. He's going to go home first. So we do the opposite to send him home. So if we're subtracting here, then we add there, and we have to do it to both sides, right? So now this cancels, and we have 3n equals 21. So let's say that this guy had to go home for dinner, right? It was getting to be dinner time. You have to go, but you've already set it up with your mom to have 3. We're n. We're identifying as n. So we sent home our -1 friend. We plussed him out. He went home. Now 3 gets to stay for dinner. Oh, that's really fun. Sorry about it, 1. But eventually the time comes when 3 has to go home too. And so now he's being multiplied by us. Now we divide. 3 over 3 is equal to 1 and it cancels. So now n is by itself and we say n equals 7. All right. So when we see these kinds of expressions, we think of our friends and the one that goes home is the one that's a little bit separate. The one that's not, we're going to be this one. We're going to be the n. We're going to have arranged for our best friend to stay for dinner, and this guy's going to go home first. That's how you know which part to do first. And there we have our answer. I'm going to do one more of these. I'm going to do practice G, because I think that's one you won't do. So it's 2x minus 1 equals 9. Okay, so here we have our friend situation. These are the two BFFs. This is us. This is the random friend. And we're going to send him home first. Again, this one was subtracting 1. This one is subtracting 1, so it's going to be the same. But let's just pretend we were adding. You just do the opposite of whatever is there. So again, we're going to add 1, 2x equals 10. We sent this random friend home first. The BFF stayed, but now dinner's over and it's time to go. So we divide him. We divide him because these are being multiplied. That cancels as 1, and we get x equals 5. All right? This I don't believe we have done before. I think this is new. So wrap your head around that, and I will see you next time. Thanks.